know what kind of day you're having, but mine is one of those days where everything I touch seems to fall apart. So this is about the third time I'm trying to do this presentation, so we'll see if this one works. If not, I'm just going to have to record it the way it is, and you're going to deal with it. So I've got a little bit of a cold, so if you can't understand my voice, I apologize. But anyway, today we're going to do a quick review of the metric system. This should be stuff that's all review to, just kind of bring it back up to the front of your mind so that it's things that we can use as we're talking about in class. In class, we're going to focus a lot more on the conversions. I'm not really going to teach this part. We're just going to work with using it. So like I said, this part should be old school stuff. But again, I know it feels a little bit awkward because it's not something that we use here in the United States. And so a lot of kids are like, why do we still have to keep learning the metric system? Why do we have to use it? Well, pretty much because Americans are more stubborn than we are practical sometimes. Maybe that's a good way to put it. We're one of only 3 countries in the world that actually still uses the measuring system that we use. Everybody else uses the metric system. So if you feel like growing up and working in anything that resembles a global community, we need to start to be able to kind of communicate in that measurement language that's used across the world. The only other 2 countries, by the way, that use the imperial system like we use, Liberia and Myanmar. So you can find those on the map, but they're not exactly world powers, not exactly dominant. The only reason why the imperial system has any traction at all is simply because America has such a dominant I don't know, force in the world that we have just decided to put our foot down and no, we're not going to convert over to the metric system except in the scientific community. So, you know, we deal with it. But we're not truly alone. In fact, we're definitely in the minority. So someday people will be, they're learning to try to communicate with our language. It's kind of weird. Anyway, in the system international, the SI metric system, there's a variety of customary units, and this little slide is up here just to kind of remind you that there's a variety of different types of things that we measure, and then there's different words that we use for those measurement units, and we call those customary units. So we can measure things, quantities like mass or length or volume or temperature, those sorts of things. And then we express those measurements in units like feet or inches or pounds or degrees or something along those lines. And there is pretty much a straightforward translation system between SI, the imperial, the metric system, and the US system. Similar ideas. The biggest difference here is that the imperial system has lots and lots and lots and lots of different units. The metric system has a very small number of base units that are customary units that they use throughout. So if you think about even in terms of length, the way that we deal with how long you measure a block, we can use inches, feet, yards, miles. There's other things, we can talk about furlongs if you want to, or we can deal with half inches, eighths of an inch, 30 seconds of an inch. In the metric system, it's just the meter. It's multiples of a meter. Is it a tenth of a meter, a hundredth of a meter? Is it 1,000 meters? It makes it a little bit more straightforward, actually, in a lot of ways. So again, we're familiar with these things on the left, and it's only because you've been brought up in this system to kind of understand the customary system, our U.S. system, that we think that the metric one looks a little bit strange. Everybody else looks at us like we're nuts. Like, why do you have different names for all these things? Why can't they all just be part of the same unit? So anyway, that's what we are. We just have to deal with it. So in terms of these different processes, how does the metric system deal with not having all of these different words? Well, they kind of do a plug-and-play system. They have the base unit, which is like a meter or a gram or a liter, a basic unit, and then we stick these grouping words on the front of them like kilo or centi or milli. There's a reason why we have different units like inches and miles, because inches are great for really small things and miles are great for really, really long things. Well, in the metric system, they have the same basic idea. Instead of using a completely different customary unit, they just use a fraction of a meter. We would call it a millimeter or a centimeter, which is quite small. That's about a centimeter right there. A millimeter is like a pinch. If you want to measure miles, something really, really long, again, a regular meter stick, like a yardstick, isn't super useful, but we would call it a kilometer or 1,000 meters in one single shot. It just makes it easier to have these kind of grouping things, but it's kind of a mix and match system. You can put any prefix with any unit and make these sort of multiple bundles, I guess, of these units that makes it a little bit easier to talk about. So the big 3 that you need to know that are on here is the kilo, the centi, and the milli. Those are the 3 that you have to memorize. The other ones that are on here you may have seen or learned somewhere else, but we don't really use them that much. They're not the ones that are used all the time. Those 3, kilo, centi, and milli, are the ones that I really need you to get. So a kilometer is 1,000 meters. It's 1,000 of any units. A centi is 100th, so like a cent, a penny, is 100th of a dollar. That's actually where centi comes from. And then milli, I kind of think of it like a mini meter, because milli is 1,000th or think of it like a millipede even. It does not mean a million though, so be very careful with that. It means a thousandth. They're actually a different phrase. Nano means a million. So, and anyway, moving forward, with these, when you're trying to decode back and forth, this is the one where students kind of start to get a little bit like, you had me and now I don't get it. The whole idea here is all you're doing is moving over decimal places. So with the big 3, when you're multiplying something by 1,000, you're really moving over 3 decimal places to the right. When you're multiplying something by 100th, like a centi, you're moving it over 2 decimal places to the left, or dividing by 100. And when you're doing milli, which is 1,000th, you're dividing by 1,000 or moving it over by 3 decimal places. So when I look at something that says like 3.5 kilograms, I think of it as 3.5, and then kilo is a bundle of 1,000 grams. So then you can just multiply them together. It's 3.5 times 1,000, or move the decimal place over 3 places, and you get 3,500 grams. Works pretty straightforwardly once you get the hang of it. Here's a couple practice problems for you to deal with. Again, the big 3 that you need are centi, milli, and kilo. And moving the decimal place over is kind of one shortcut way to do it. Or you can think of it as multiplying or dividing. So kilo would multiply by 1,000, centi divides by 100, or milli divides by 1,000. So with these, if I have these numbers down below, like 2,341 centimeters, and I want to convert it to a base unit, which is a meter, I need to remember that centi is 1/100th of a unit, so I would divide this number by 100, and I would get the number 23.41, and that makes sense to me. The 45,000 milligrams, again, is it 45,000? Yeah, I can't even count those zeros. Again, a milligram is 1/1,000th of a gram, so I would have to divide this number by 1,000 to get it to grams, or move the decimal place over 3 to get 45 grams. And 2.743 kiloliters. Kilo is the big one, so in this case I multiply by 1,000 as opposed to divide by 1,000. So if I move the decimal place over 3 places, I get 2,743 liters. Again, it just takes some practice in terms of which way you're going. Are you multiplying or dividing? Some customer units. We're just going to kind of go through a series of slides here on some of the different things that we measure different stuff with. That was brilliant. So if we're talking about length, what are the units that we use to measure length? What do we use to measure volume or whatever? So for length, we use the meter, or a fraction of a meter, like a centimeter. A centimeter is about this long, about 2.5 centimeters to an inch. And if you ever need that sort of conversion, 1 inch equals 2.54 centimeters, you don't have to memorize it. I'll give that to you. So don't worry about those sorts of English to metric conversions. Only metric to metric is the only ones I really care that you have to memorize. Other customary ones? A meter and a yard are just about the same thing. A yard's a little shorter, so if you hear about the 100-yard dash, it's very similar to a 100-meter dash. A 100-meter dash is just about 3 inches each longer. A yard's 36 inches, and a meter is about 39.5, just to give you an idea. A kilometer compared to a mile, though, is a bit shorter, which is kind of weird. A kilometer is just over half a mile. So miles are definitely bigger units than kilometers are, but it's just kind of the way it worked out. They weren't trying to make it neat. They were just trying to make the math easy. In terms of dealing with length, I know it gets really weird to kind of think about converting back and forth. For me, it's a lot easier if I just kind of get in the metric system and stay in the metric system, rather than trying to translate between the two. That gets a little bit harder to deal with that. And again, I'll remind you that the English system only seems easier because you know it. We're here in the metric system just multiplying by tens or hundreds or thousands. In the English system, just to go back and forth in length, you're going 12 inches are in a foot, 3 feet are in a yard. I think it's 1,260 yards are in a mile, 5,280 feet are in a mile, because that makes sense. You know, we can talk about even bigger versions of that. It doesn't make a whole bunch of sense, as opposed to if we're trying to do some crazy conversion in millimeters to kilometers, you can actually kind of do this in your head. If I tried to ask you to go, you know, how many inches are in a mile, you have to get a calculator out to do it. But to do millimeters to a kilometer, it's actually just a matter of moving over the decimal places. So 35 kilometers is simply multiply by 1,000 to get to meters, which is 3,500. And then if I want to go from meters to millimeters, millimeters are tiny. There's 1,000 millimeters in each meter, so I can just multiply it by 1,000 again to get it to millimeters, which is tiny. Again, you try to do this like inches to miles, you'd have to get a calculator out, because there's just so many weirdness that goes on there. So again, you don't have to do these in your head, but it is certainly easier if you're just moving decimal places over. Okay, dealing with volume. Volume is by far the most miserable of all of the different measurement systems in English. This is the same slide that I've been having trouble with, so I'm going to keep clicking on it until it works. But one of the things I want you to think about with volume in the English system is the concept of how many different kitchen units there are. Because most of our units in our kitchen There we go. Finally came up. That was weird. Most of our kitchen units, things like cups and gallons and quarts and things like that, are actually measurements of volume, liquid volume. So just to kind of keep this in mind, gallon, quart, pint, cup, you can talk about there's, I think, 2 cups in a pint, 2 pints in a quart, 4 quarts in a gallon, I think. And then you got teaspoons and tablespoons, which are like the little spooners that you would use. There's 3 teaspoons in a tablespoon. I have no idea how many tablespoons are in a cup, though. Nobody does. And then we can talk about fluid ounces. There's 8 ounces in a cup, but a fluid ounce is different than like 16 ounces are in a pound. Those aren't even the same thing, even though they use the same word. They're bizarre. So anyway, there's tons and tons and tons of fluid volumes that we can deal with, big ones, little ones, etc. For you guys, if you want to know just customary, a quarter of a gallon is about a liter. So a liter, there's about 4 liters in a gallon, roughly. It's a pretty good guess. If you're dealing with volumes of cubes, of solid things, we just base them on lengths. So we don't deal with other weird systems. If it's length times width times height, and your 3 lengths are all in meters, then we just use cubic meters. Or we would call that cubic miles, I guess, if you try to do it, or cubic feet, cubic yards. You might hear in an English system, like you get dirt delivered to your house in cubic yards. It's kind of a weird thing. Your refrigerator volume is probably measured in cubic feet. And again, it's just a foot by a foot by a foot. So it works out pretty good. Important fact down here in the bottom, make sure that you take note of this somewhere because we do use this a lot, that a milliliter and a cubic centimeter are the same thing. If you've ever watched medical dramas, they always talk about saying, I need 30 cc's of such and such stat. A cc is a cubic centimeter. So even in the medical system, they use the metric system. So keep that in mind. Okay, moving on. Mass and weight. This is kind of a little funky piece. They're a little bit different than we expect. Mass and weight are not the same thing, at least scientifically. Mass is kind of the measure of how much stuff, how many atoms you have in you, and weight is actually a measure of gravity's force on you. So if you go up in space, you don't lose any mass, but you lose all your weight. You're weightless, but it certainly doesn't change your mass at all. The weight that you know of as pounds is actually not a mass. That's actually a weight. It's in gravity. The English unit of mass is actually something called a slug, which you've never heard of because nobody ever talks about it. In the metric system, we call weight newtons and we call mass grams. It's actually kind of funny that we call it a newton because supposedly Newton invented the idea of gravity when he was sitting under a tree and an apple fell on his head, and it turns out that an apple basically weighs about 1 newton. So, haha. Anyway, so just one of those little things. Typically, we're going to be dealing with, in this class, we're going to be dealing with grams and kilograms. It's not really until we get into physics that we deal with newtons a whole lot, so you don't have to stress about it here. Just as an FYI, a kilogram is heavier than a pound. It's about 2 pounds. So if you want to know what your mass is in the metric system, basically take your weight in pounds and divide it in half. A gram measurement is actually very small. A paper clip or a cotton ball, or even like a piece of paper the size of a dollar bill, is about 1 gram. It's not a big mass at all, not like a pound is. We don't really have a common mass that we use in the English system for really small masses, other than ounces, and a lot of people don't know what ounces are, so that's kind of a weird one. Okay, moving on to temperature. We can talk about temperature in the English system versus Fahrenheit versus Celsius. A couple key things here to keep in mind is that the Fahrenheit system was basically designed in Europe to accurately measure European temperatures. It's kind of weird. So the coldest it ever got in Europe was considered to be 0 Fahrenheit, and the hottest it ever got was supposed to be about 100 Fahrenheit. That's kind of how they did it. So if you don't live in Europe, then you have no idea what that means. But the Celsius temperature system is based on the physical properties of water, so it kind of takes that away. In terms of 0 is the freezing point of water, and 100 is the boiling point of water. So the little pictograph over on the right there has some different numbers that kind of make sense, like water boils at 212 Fahrenheit. That's so random. It's 100 degrees Celsius. Body temperature is about 37, plus or minus a little bit. Room temperature is roughly 28 or so, 27, 28 Celsius. Water freezes at 0, like I said, and you can kind of look at some of the really cold ones. I like the air liquefies one. But again, just keep in mind that the Fahrenheit one was definitely very ethnocentric. It was definitely based on European culture. I think it's really funny that you go up to Canada and they say, oh, it's 50 degrees outside. They think we are literally on fire because 50 degrees is incredibly hot, way hotter than it's like 130 degrees or something like that. So it's kind of ridiculous. That's the picture over there. But it definitely is not like that. There is a little formula for it. We'll talk about it in class, but there is a little conversion that you can do to go back and forth between the two. So yeah, not a huge deal. All right, to review, in terms of what are the things that you really need to take away from this. Number one, make sure that you understand that the only reason why the metric system is important is because everybody uses it, except us. It's a really simple system of base units and prefixes to multiply up and multiply down. You don't have different words, and you don't have different conversions between every possible unit. It is kind of nice because you can have any base, any prefix. So keep that in mind, that if I say kilometer, I could say kiloliter, or I could say what did I not say? Kilogram. Any base, any prefix, it works together, mix and match, kind of makes it nice. These are simply based on powers of 10. We're only picking the hundreds and the thousands because it's kind of big, those big grouping terms, but there is any base of 10, you can have some sort of a metric system, that metric prefix that goes along with it. But there's those three big, one that you need to know, the kilo, the centi, and the milli. So you're either multiplying by 1,000 to get to kilo, you're dividing by 100 to get to centi, or dividing by 1,000 to get to the mini-meters, the millimeters. And then again, just keep in mind that don't go too insane with all of this. This is just a familiarity piece. A lot of what we're going to deal with is the conversion process in class. You don't need to memorize metric to English conversions, like how many pounds are in a kilogram. Not at all. I will give you any of those that you need. I just need you to memorize the 3 metric conversions. So there you go. Review of the metric system and some kind of the crazy metric units, or the crazy English units, I guess, the logical metric units, and some of the reasons why we use them. So there you go. We'll start working on conversions in class tomorrow. Have a good day. Oh, yay, I finally got this one to work.